Hello and welcome to the first video in our Geotechnical Design Guide video series. My name is Josiah Baker and this is Jennifer Laybourne, and we're staff engineer here at the Cambodia office. In this video, we will explain the process of identifying soil types in the field with the primary objective of classifying its soil type as well as some of its characteristics. This video is intended to accompany the Geotechnical Design Guide, which provides all this information in written form to expand on some of the concepts that we'll be presenting here. So there are two main types of soil classification systems. The first is the USCS classification system, which is primarily used for engineering purposes. The second is the USDA classification system, which is primarily used for agriculture. In this video, we'll focus exclusively on the USCS method. The Civil Engineering Design Guide has a comparison of the two methods, so if you want more information on how to compare the two systems, please look to the guide. The key to producing useful information when you're in the field is careful documentation. So one way that you might want to do this is writing on your sample bag. Be sure to include information like the date, the location, the depth that you retrieved it, any unusual conditions that you observed at the surface of the ground, if you encountered groundwater at any point, and other pertinent information that might be helpful. It is important that when you're recording this information that you're able to understand it when you're back in the office so that you can reduce it for further use. Something that you'll also want to bring when you're in the field is the soil boring log, which we've produced as part of the design guide. So you'll want to take this with you when you're on the field as an aid to classifying and characterizing your soil. We'll go over some of the characteristics that are highlighted in this boring log legend.
So now we'll look at classifying some of the soils. So in visually inspecting soils in the field, some important characteristics to note would include the color, the moisture, the texture and consistency, and the odor, if there's an odd smell, or cementation, which we'll discuss later. In the USCS method, there are two different types of soils that can be classified. Coarse-grained soils, which have individual particles that you can see with your eye when you hold the soil in your hand and move it around. This soil behavior is primarily controlled by particle-to-particle contact between the soil particles, and there's also fine-grained soils, which are not visible to the naked eye and their behavior is controlled by electrochemical forces. Examples of coarse-grained soils are your gravels and your sands. Fine-grained soils would include silts and clays. We can also encounter a subgroup of soils called organic soils. These are typically fine-grained and formed by decomposing vegetation. They usually are a dark layer in your soil stratigraphy. So their presence can lead to unsatisfactory soil performance, including low soil strength and excessive settlement. So it's really important to try, while you're in the field, to be aware of this soil layer, to look for it, and to plan your design around it. As we mentioned previously, soils can be divided into two categories, the coarse-grained and the fine-grained. And some laboratory tests can really aid in precisely determining how much of your soil is coarse-grained, how much of your soil is fine-grained, and better characterize which behavior will dominate the soil. So in a laboratory, the number 200 sieve can be used to distinguish between the coarse-grained and the fine-grained sample. And a full sieve test can be used to classify the coarse-grained material even further into coarse gravel, coarse sand, fine sand, and then your fines. And that will result in a gradation curve, which will also help you see if your soil is poorly graded or well graded. Poorly graded would have all particles of a similar size, and the well graded would have an even distribution of a lot of different particle sizes. For fine soil, you can use the Atterberg limit test, which we have here and will be described in a separate video. This test can be used to distinguish between the fine-grained soils of silt and clay, which are hard to distinguish in the field.
So the first thing that you'll note when you're observing your soil sample is the sample color. So we have a few soil samples here to show you guys. The important thing that when you're classifying its color is to keep the color simple, and you need to keep it simple so that you can easily communicate with your contractors or with your clients about the types of soils that you have on the site. One of the first things that you'll want to comment on when you're creating your boring log or your sample log is the soil moisture content. And this is all the same soil sample at different moisture contents. The one on this side is a dry soil sample, and dry soil samples are characterized by their dry or dusty appearance. For fine-grained soils, the dry samples might be very hard. The second sample is in the moist or damp condition. The moist condition is usually when the soil begins to darken by the presence of some moisture. And the last one is when the sample is in a wet condition. These soils are usually found near the surface of the groundwater table, and when you retrieve the sample, there's visible moisture at the surface of the sample.
So soil texture is a description of the soil particle size and gradation for coarse-grained soils and the behavior for fine-grained soils. To determine a precise gradation for our coarse-grained soils, we use a set of sieves to separate between the gravels and the sands on a number 4 sieve, and between the sand and fine-grained materials on the number 200 sieve. General observations by eye and by feel can be used in the field. Sand will be gritty, and you'll be able to see from some of our samples the visual difference in size between gravels and the sands, especially in this sample. So we also have density and consistency, which are used to describe the resistance of a soil to deformation and rupture. This is difficult to measure in the disturbed state that you would be doing in a typical field test if you're doing hand augering or digging, but we will discuss this testing for soil consistency in a future video. So coarse-grained soil would be described by its relative density, which would range from very loose to very dense. And the fine-grained soils are described by consistency, ranging from very soft to hard. And so it's helpful to get an understanding of how the soil has been deposited and whether it's very soft and squishy and maybe doesn't have a lot of strength, or if it's very dense and hard and you'll be able to really rely on the soil strength for your foundation.
One thing that you'll also observe in some soils is cementation. So in some soils, they behave more like a rock, and you actually have to use quite a bit of force to break the particles apart. So cementation ranges from lightly cemented, where it's pretty easy to crush with your hand, to well cemented or highly cemented, where it's harder to actually crush the soil. So this one is a little bit harder, and I'm applying quite a bit of force and it's not crushing. So we would call that a highly cemented soil.
So for coarse-grained soils, you can also note the angularity and shape of the grains if they're large enough and significant. Angularity describes the roundness or angularity of a particle. If a particle is spherical and very rounded on the edges, it's good to note maybe it had been in a stream or some type of body of water that smoothed out all of its rough edges. Also, for shape, some soils are very flat or elongated, and those are good things to also note.
One thing that you might also want to note is the odor of the soil. The odor of the soil might give an indication of the presence of things such as organics, or if there's a chemical smell, it might indicate that there's some pollutants such as gasoline or petroleum. For coarse-grained soils, we'll typically categorize it as either gravels or sands. Like we described previously, for particles with an average diameter greater than 4.75 millimeters, we'd characterize that as a gravel. And for soils that are smaller than 4.75 millimeters, we'd characterize it as a sand. Another thing that you'll want to document when you're characterizing coarse-grained material is its gradation. So our two types of soils that we have here represent two different types of gradations that you might characterize for coarse-grained material. The first is what we would call well-graded. Well-graded, as you can see here, has a wide distribution of particle sizes from gravels all the way down to silty material. Well-graded means that there's decent distribution for a lot of particle sizes, especially around the median particle size, which in this case is a coarse particle size. The other gradation we have here is poorly graded, and as you can see, there's poor representation of for coarse particle sizes as well as fine particle sizes. So there's really only one particle size, which is medium sand, being represented in this sample. For fine-grained soils, you'll also want to comment on the soil plasticity. Plasticity is the ability of the soil to undergo deformation when applied stress. For coarse-grained soils and for sands and gravels, when you apply a force, the particles separate, but with clays and silts, as you apply a force, they actually can squeeze and stretch. Low plasticity fine-grained soil is a soil that can only undergo a little bit of stress or strain without beginning to crack. And a high plasticity soil is one that you can roll into a thin thread. It's a soil that can undergo a lot of strain when applied stress. We'll now go through the process of identifying soil types in the field. The important thing when you're characterizing soil is to actually grab some sample and feel it with your hands. So you'll start by taking a soil sample that you retrieve from the field and rubbing it in your palm and between your fingers. If there's some grittiness, there's a high chance that it's probably a sand or it has some sand in its texture. If you roll it and it feels smooth, it's probably a fine-grained soil like a silt or a clay. For fine-grained soils, classifying the soil type is a little bit more difficult and requires more experience. So you'll begin by taking your soil sample and attempting to roll it into a thin thread. So for fine-grained soils, you'll begin by trying to roll it into a thread, into a 3 millimeter thread, which we would classify as the plastic limit. The plastic limit is the point at which the soil changes from behaving like a plastic with high moisture contents to a solid at drier moisture contents. So for the two main classifications for fine-grained soils are silts and clays. So a silt, once it's drier than the plastic limit, will actually tend to crumble, and it's hard to re-roll it past the plastic limit. So this one, I'm having difficulty rolling it beyond its plastic limit, so we would probably characterize this as a silt. This one, we can re-roll it. We can roll it and re-roll it into a thin thread several times, and so we would probably classify that as a clay.
So once you have performed a visual inspection and determined the soil type, combine all of your observations into a concise soil description. The boring log legend that we mentioned at the beginning will help walk you through this process. Combine all of your observations, color, moisture, particle size into a soil description to easily characterize your soil.
Thank you for watching our video on soil classification. If you have any more questions about how to classify soils with the USCS method, please look at our GeoTech design guide for more information.